Welcome back to Creating Stuff with Jim. I'm Jim. It's time to create something. In this episode, I got an interesting project that I'm going to share with you. The other day I was down visiting a shop that was doing some body work on one of my dad's cars, one of his antique cars, and as I was talking to one of the guys, and he had a very interesting project of his own. He was building an antique British race car. So he's modifying himself, doing his own body work. And really looked kind of neat. You'll probably see a picture of it or a short video of it at some point in this episode. But while I was there, he asked me if there's something I could do for him, and basically he needed this aluminum fuel tank modified to fit his car. So I took a look at it and said, sure, absolutely. So I went ahead and he showed me what he wanted, and so I was more than happy to take on the task, and I figured I'd share it with you guys. But basically this is more or less just a universal fuel tank that he bought, this aluminum, and what he wants to do is, this is a fuel cap. I don't know where he got it from or what this is for, but basically he wants this fuel cap is going to be mounted on the body of the rear of the car. I don't know, deck lid, something like that. Anyways, this is going to be mounted in the back, and we need to make a filler neck to go inside this fuel tank. So, since the tank's aluminum, I went ahead and got a piece of aluminum pipe that has a pretty close diameter to the fuel cap that I got to put in. So that's going to work. And I've already got a picture. I've already looked at where he wants it, and I've already put a mark where it's going to go with the orientation in the car. So it's not going to exactly be on center, and here's the kicker, not only is it going to be on the side, but we're going to probably have to put a 10-degree angle on it as well. So it's not just the pipe is just not going straight into the tank, it actually has to be angled a little bit. So basically we're going to have to notch this pipe, and it notches this pipe to go to fit the angle, to fit the curve, and then it's also going to be angled about 10 degrees. So that's going to be an interesting cut we're going to do, but I got a pretty good idea how we're going to do this. So anyways, so after we weld that on, and then he also this is only going to be about maybe 3 inches tall at the most. He also wants a port, a threaded port in there. I'm going to do an 1/8 inch pipe thread, so you can put a vent tube in there. So we're going to do that as well. So, but how we're going to do this is we're going to cope the end of this to match this fuel tank. After we have that coped, then we're going to go ahead and weld a hard point. We're going to weld a hard point on this, grind it flat, so we can drill and tap the 1/8 inch pipe thread. After we get that done, then we're going to come in here and we're going to weld it on. We might cut it off at that time. I don't know yet. We're going to have to figure out how this is going to. The plan may change as we go along. Yeah, so when I go to weld this pipe on, I'm actually going to not drill a hole in this until after this pipe is welded on. I'm going to do it that way so there's more material, more metal to absorb the heat when I weld it. Because if I cut it, then the other side of it is, if I cut it and I set the pipe, then there's a gap. And anytime you weld aluminum, gaps are hard. Well, for me, they're hard. So anyways, so what I'm going to do after I fit it, I'm going to weld it. And then this is only going to be about 3 inches long or less. I'm going to take a hole saw and I'm going to go through the center of it and drill that out, pull the piece out, clean it out, call it good. So, but that's the plan. And how I'm going to end up marking this so I can coat this out, so I can get that to fit the way I want, is I'm going to use CAD, and I'm going to draw up a 3D model that will slide around the outside of this pipe. It'll have the exact shape I need. I'll actually use the 3D printed part in order to test fit, I'm going to put this in the car and make sure my angle's right. As long as the 10 degrees is going to work. If I got to change that, I can change it. And then when I slide the plastic model, then I'll 3D print that, slide it over the pipe, and I'll use that to mark the pipe where I can cut it. So, and really what this is going to show is on how much of a place CAD and 3D printing and all this stuff I've been using has a place in the home shop these days. Where this stuff was kept for high-end manufacturing and engineering, but the truth of it is, it's very common, readily available. It's not expensive and it's not hard to use. And I truly feel like it is just another tool in the toolbox, just like a 9/16 wrench. And CAD and all this stuff has a very good place in the home workshop these days. So anyways, enough with that. And I'll tell you what, I'm going to jump on the computer. I'm going to design the 3D printed piece to template for this and go from there. So enough yakking. I think I need to get to work. Well, now that we got our template made, and actually I made two of them because one is leaning back 10 degrees and the other is only leaning back 5. So they both fit the fuel tank just about perfect. And but now I'm going to take the fuel tank, I'm going to take both of these, and I'm going to go test fit it in the car just to see which angle is going to work better. So that's why I did two separate ones, and then if I need an angle that looks like it's going to be more than 10 degrees or less than 5, then I'll make another one and mock it up again. So let's head on over and we'll do a test fit on all this. Well, this is the project car that fuel tank is going into. It is a Triumph Spitfire that is fully customized to be a race car. And I gotta say, this car looks like it has a lot of potential, and I think it's going to look absolutely amazing when it's done. Well, and this is where the fuel tank mounts, and where the mock-up piece is where the filler tube's going. And I tried both the 10 degree and the 5 degree, and it looks like the 10 degree fits the best. All right, now that we got the test fitting done, we found out that the mock-up that is leaning 10 degrees back is the proper fit. Looks like that's going to work really well. So now we're just going to take our aluminum pipe. It's going to slide over, and since we put the slit in it, you can clamp it down tight. And now we're going to trace it out with a Sharpie. And there we have it. That's our line. This is all the material. This is all the material that we have to remove. So now I'm going to get someone to do the cutting and grinding for me, and then we're going to come back and test fit it. All right, we got it all. We got it all ground down, and is like I said, worked out pretty well. Is all I did, like I said, the sharpening mark that was on there, they just ground down to that mark and then cleaned it up. Had to clean out the inside a little bit. And that looks pretty good. Now let's see how it fits on the fuel tank. That doesn't look half bad. That shouldn't be too hard to weld. And but before we weld this on, is basically I need to. I'm going to end up probably just I'm going to weld a little bit of material on here just so I can build it up, so I can grind it down for a flat spot. I'm going to drill and put an 1/8 inch pipe thread in here for the vent hose. So then after we do that, then we can weld it onto the tank. Let's get to it. Alright, in the last clip you saw, basically I got the, I built up the aluminum where I wanted to drill and tap so I could put the 1/8 inch pipe thread. I welded that up, drilled and tapped the 1/8 inch pipe thread so for the vent hose that's going to go inside of this. So that went fairly well, and that's actually the nice thing about working with aluminum is, like I said, I mean, I can just stack dimes, weld that all up, then grind it flush and drill it. And then if I screwed the threads up in that, guess what? I could weld that hole back up and then drill it again. As long as you get a good bead on there, it sticks. So that works really well. So now we got to weld this on the fuel tank. And we got the fuel tank over here on the bench. I'd screwed down a couple 2x4s on either side just to keep this stable. And you can see right here, that's my mark where it's going to go, and I cleared up around it. So, and just so I can sound like a broken record, the reason I haven't cut the hole in this yet and I'm welding it on like this is basically I want to leave as much metal in this as possible. If I cut a hole and fit this in here, I would actually have a pretty good gap around where the pipe meets the tank. That gap is hard to fill, and then you have thin metal right here, so it's going to tend to warp. It's going to warp very easily. So so by leaving this intact, I'm going to keep the rigidity of it. I'm going to keep more metal in here so I don't have an edge so it can absorb heat. And by leaving all this excess pipe on it for now, once again, that's just more metal to absorb heat. Now, and I'm going to probably end up having to stitch it in a little bit at a time, because as thin as metal as this fuel tank is, I don't think it's not going to take the heat. It's going to want to warp pretty bad, so you got to take your time. So so that's the reason for that. And then how I get the hole in the tank is, excuse me, after I cut this off, I'll go through the center of it with a hole saw and then drill the hole. So that's how that's going to work. Now, and if anyone's wondering what welder I'm using, I'm using a Thermal Arc 186 AC/DC. There is absolutely nothing special about this machine. When I bought it, it was relatively new on the market. And the best way to put it is, this is the cheapest TIG welder I could buy at the time that will weld aluminum. And the biggest thing about TIG welding aluminum is you have to be AC high frequency. If you don't have the high frequency, it won't weld. The only way you can weld DC aluminum is you have to use wire feed with a spool gun and a MIG welder. So, anyways, just my personal preference. I like anything 1/8 inch or smaller. I like to TIG weld it. Anything thicker than 1/8 inch, I wire feed. So that's generally how I like to do it. And the truth of it is, and this machine is by no means the best. In all honesty, it's the farthest thing from it. Because the biggest thing is like the amperage control. Like I said, most welders use foot pedals to control the amperage on the welder. On the TIG welder, I use a thumb wheel. That's just how I learned. That's how I use. But I will say the one drawback of this machine is it actually has a very significant delay when you ramp the amperage up or down. There is a very noticeable delay in it. So, but you know, I'm not doing critical welds that are going to get x-rayed or anything like that. Nothing life safety by any means. So, like I said, it works for what I do. And you know, I am a cheapskate, but you know what? Having a cheap tool that can do the job is better than wishing you had an expensive tool to do the job. So, anyways, well, let's get to it. I'm gonna get to welding. All right, I got a couple stitches in there. Kind of look a little ugly. It's getting a little warm, so I got a little close. It was a little hard. Had a little trouble tacking it. But like I said, this is getting a little bit warm, so I just want to wait, let this cool off, and I'll go back, stitch it in. When you rush something like this, especially how thin this tank is, very, very thin. When you rush it, that's when you put a big old hole in it, and it just gets a lot worse. So sometimes it's better just take your time and don't screw up. So well, once again, this is getting really hot, and if I did not leave this tank intact, this thing probably would have worked pretty good. So all right, well, let this cool off. I'll bring it back when I got some progress. All right, I got it all welded in. It's really, really hot right now. So these welds came out halfway decent. I'm kind of happy with them. It is kind of got a little crazy over here. I was chasing a couple pinholes. But now that I feel confident I have it welded on, the nice thing is it generally cools off pretty quickly. Like I said, it didn't take me too long to get this stitched up. Like I said, I was just able to cool it off. The nice thing is having this extra pipe on here. This is a fair amount thicker, so I could just let this absorb all the heat at once. This cools off a lot quicker. So, but I'm gonna just let this cool naturally, and then I'm gonna come back, and I'm actually gonna fill it up with water. Make sure, well, just up to the place where I have the plug, and just make sure I don't have any leaks. And so then if I'm leak free, then I'll cut this off, drill the hole in the hole saw, and dress it up a little bit, and it'll be done. So we're gonna come back when this cools off a little bit. Well, now that I got the new fill neck welded on, after I leak tested it, I actually had to go back and chase a couple pinholes. So like I said, some of the welds look a little sloppy, but the most important thing is they're gonna hold and they don't leak. So, and besides, all my welds have a lifetime guarantee. If they break or leak, bring them back, I'll re-weld them. So I don't see where you get made guarantees like that in this world. So anyways, so that's all welded on. It's looking good. So now I got it marked. Now we got to cut this off. So I'm going to leave about 1 inch above the pipe thread where he's going to put a hose clamp to put a rubber hose on to go up to the fill cap. So now we're going to cut that off, cut the hole, take the hole saw, cut the hole through the inside, and then we're just about done with this. So let's get to it. Now they gotta cut it off, and now we're just gonna clean up the surface of that. I'm just using my grinder with a flat disc. All this is an overglorified sand. All right, doing pretty good. My centerpiece stuck inside the hole saw like it does most of the time. That's great, 'cause I didn't feel like having to dig it out of the tank. And there you have it. I got a hole in the middle. I gotta tell you, I'm pretty happy how that turned out. I mean, unfortunately I have a big old wad of crap for a weld right there, but that's what I had to do so it wouldn't leak. So anyways, unfortunately I'm not the best welder, but the truth is, if it doesn't leak and it holds, what's so bad about it? But anyways, there we go. That actually turned out pretty nice. I'm happy with that. Well, this project is done. It turned out pretty neat. I'm real happy with it. So, and I gotta tell you, it's not very often that you have a custom Triumph Spitfire race car that you gotta build a custom aluminum fuel tank for it. So I think this is pretty neat. So, but anyways, I hope you enjoyed the video as much as I like doing these projects. And but with all that being said, if you like the video and you're not subscribed, please subscribe. And if you did enjoy it, please share it with your friends. So, and there's a possibility I might be building something else for this race car, but the thing of it is, you're gonna have to subscribe and follow my channel if you want to see it or not. So, but anyways, I'll see you next time.